Hello everyone, very good evening and welcome to the BYJU'S exam prep, the most comprehensive app for all competitive exams. This is Sanjay Rathi guys. Now it is a special 26 series, तो आप लोग इसे जरूर enjoy कर रहे हैं and that is what I am going to take very important topic, that is semiconductor physics from electronic devices and circuit. Okay, and here I am going to give you idea about the topics, as well as we will solve some important numericals on that, and it is a quick revision of semiconductor physics. Chinmay Roy, very good evening everyone. And now this is my introduction. Myself Sanjay Rathi, 23 years of teaching experience, and these are my ranks in engineering services exam, and I have trained more than 1 lakh students for these competitive exams guys. Okay, and now what are the important topics from EDC? That is semiconductor physics. Second is what PN junction. Third one is what BJT and its characteristics, like common emitter, common collector, common base. Then what MOSFET, its characteristics, okay, transfer characteristics as well as output characteristics. And then MOS capacitor, that is very important one. So in 3 sessions I am going to cover all these topics. And finally guys, one very important the topic, that is what is spatial diodes. We are getting question, but normally formula based questions. Okay, so that is in first session we are going to take what semiconductor physics. Then this is my telegram channel, Electronics by Sanjay Rathi. I will upload the PDF of this session on my channel, and if you have any doubts then you can join my telegram channel. And these are our results in engineering services exam 2023. 5 under 10, 29 aspirants under 50 and 37 under 100. Okay, so if you want to give the engineering services exam with GATE, then you can start your journey with us. Now types of semiconductor. Without any delay I am going to start my session. So ask your friend to join the session now guys. That is first of all, get the all detail about it. Is it audible everyone? Is it audible? Okay, I think sound and picture quality, everything is fine. Hello. Okay, now guys, first of all, get the idea about that semiconductor. There are 2 types, intrinsic and extrinsic. Everything about n type, for example, what is pentavalent impurity, what are the trivalent impurity, acceptor impurity, for example boron, indium, right, gallium, and then that is what arsenic, antimony, phosphorus. These are the pentavalent. Sometimes we are getting very basic questions, MSQ. MSQ means multiple select questions, so we can get very easy questions also. To get the complete detail about that, then, and these are the important parameters. Sometimes they will provide you the important parameters, but if they are not going to provide you, then you have to use it. For example, electronic charge, electronic mass, ratio of the charge to mass, Q by M ratio, and then what Planck's constant, 6.62 into 10 to the power minus 34. Normally Planck's constant is required in case of what, when we are giving the radiation and LED, and when electron excited from valence band to what, conduction band, hc by lambda. That is the Planck's constant is required, but we have the shortcut formula for that. Boltzmann constant, that is in joule per Kelvin. Here the Boltzmann constant is what, electron volt per Kelvin. So what is the 1 electron volt? 1 electron volt means 1.6 into 10 to the power minus 19 joule. Right, right. So that is the Raj. Is it audible? Yes please. Hello. Yes, na, then okay. So these are the important parameters, 1 electron volt, and what that is the value. Please get the idea about that. We have to use all these values when we are going to solve some numericals. Okay, then this is about what when we are giving the impurity, for example arsenic, antimony, phosphorus, pentavalent impurity, and then acceptor means boron, gallium and indium. So these are the atomic numbers, right? But remember, these are the pentavalent and trivalent impurity. More than sufficient information here for n-type and for p-type material. Then this is a very important diagram, guys, when we are dealing with the conductivity and so on. So we have to use the formula here. I'm going to just quickly explain this. Okay, for example, sigma n q mu n plus p q mu p, that is called conductivity, and J is equal to what? Sigma E. I'm talking about the drift velocity or drift current density. Then J. So that is the mobility. What is the dependency of mobility on the electric field up to that certain limit, that is normally 10 to the power 3 volt per centimeter and 10 to the power 4 volt per centimeter. That is the electric field. Mobility up to this point remain constant. Here mobility is proportional to 1 by root E, and here the mobility is proportional to what? 1 by E. And because of that, here the drift velocity increases linearly, then what? Sublinearly, and finally it will become constant. So that diagram is very important, but again that is one question in our mind. Which type of question, sir? This is the question on this diagram, mobility and electric field, in GATE 2017, 2 marks set 1. Watch this. Same diagram, but there is some approximation. That portion, sublinear portion, is not given. See, direct constant. Only two levels, linearly and what? Constant. So that is the question. What is the answer for this? The dependence of the drift velocity of electron on electric field in semiconductor is shown below. The semiconductor has uniform electron concentration means N, and the electronic charge. If a bias of 5 volt is applied across a 1 micrometer region of this semiconductor, the resulting current density in this region is, what is the resulting current density? You have to solve. Is this electrical engineering syllabus or not? And you are talking about which exam? You are talking about which exam? If you are talking about the GATE exam, then that is not in syllabus. If you are going to give the GATE with electronics or engineering services, then in material science, but basic only. Now, so that is the current density. First of all, remember, to solve this question, tell me what is the answer here? What is the answer here? Okay. First of all, sigma, right? And what is the J? Current density. Sigma E. You have to use this formula. Then what is about the electric field? We are giving the 5 volt here. That is given in question. What is the length of this bar? 5 volt is applied across 1 micrometer. 1 micrometer means 10 to the power minus 4 centimeter. 5 volt is applied. So what is the electric field here? Volt upon length. 5 volt upon 10 to the power minus 4. You will have 5 into 10 to the power 4 volt per centimeter. 5 into 10 to the power 4 volt per centimeter. That is the electric field. Now, watch this diagram carefully. Here it is 5 into 10 to the power 5 volt per centimeter. It will increase linearly and then it will become constant. So, what is the drift velocity exactly at 5 into 10 to the power 4? You can find the 5 into 10 to the power 4 is here. 5 into 10 to the power 4 electric field is here. Means what is the drift velocity at this point? You can find the drift velocity. What is the slope of this line? The slope is given by, what is this? 10 to the power 7 upon 5 into 10 to the power 5. slope, that is represented by m, 10 to the power 7 upon 5 into 10 to the power 5, that will become 1 by 5 into 10 to the power 2, or 100 by 5. 100 by 5 means what? 20. So that is the slope. Now exactly at this point, what is the drift velocity? So you can find the drift velocity, that is given by slope into that is the electric field. So that is the slope. And what is the electric field at this point? 5 into 10 to the power 4. This is cancel out. And what is the electric field? 10 to the power 6 volt per centimeter. Drift velocity. Not this is the drift velocity, volt per meter per second. Drift velocity is given by, at this point, that is the electric field multiplied with the slope, that is the 10 to the power 6 centimeter per second, because we have used that is the volt per centimeter, that's why it is in centimeter per second. Unit is clear. This is given centimeter per second. So it is just Badam, okay. Sorry, Amrinder Reddy. Okay. Then what I want to say, first of all, watch this line. What is the change here? This is given curve. After that it is saturated. So at which point it is saturated? And what is the saturated drift velocity? 10 to the power 7. Right? And that is 5 into 10 to the power 4. 5. And what is our electric field? Is this one. I have find the electric field. 5 upon 10 to the power minus 4. The electric field is 5 into 10 to the power 4. So what is the 5 into 10 to the power 4? At this point we are having the 5 into 10 to the power 4. What is the drift velocity at this point we have to find? How we can find? First of all, you have to find the slope of this line. So what is the slope of this line? This change upon y2 minus y1 upon x2 minus x1. So what is the slope here? I have given 10 to the power 7 upon 5 into 10 to the power 5, and that is 1 by 5 into 10 to the power 2. That is the slope. Now at this point, what is the drift velocity? You can find the slope multiplied with the change. Slope 10 to the power 2 upon 5 into what is the electric field? 5 into 10 to the power 4. So you will get 10 to the power 6 centimeter per second. Is it clear now, everyone? Right. So this is the case. So then you have to multiply it, and then you can find it. So one, you have the idea about that drift velocity. So what is the current density, guys? Current density is given by J. What is asked here? Current density is asked. Resulting current density in this region in kilo ampere per centimeter square. So remember, J is equal to sigma E. So what is the sigma n q mu n into E? Mu n into E is nothing but drift velocity. N is given. What is the concentration here? 10 to the power 16 into 1.9 into 10 raised to power minus 19. And what is the mu n you have calculated? 10 to the power 6. Now, so this is a very simple calculation. Now you can do the calculation. This is that simple 10 to the power 6, 10 to the power 22, 1.9 into 10 to the power 3 ampere per centimeter square. So what is the answer? Check my calculation. That is the basic. Okay. Special 26, yes, you can follow this series. So this is a quick revision. So this type of question, and that's why this diagram, this theory is very important one. Remember. Second thing about that, sometimes they will ask about what lattice scattering. So when the temperature is low, almost 100 degree Kelvin, just below 100 degree Kelvin, impurity scattering is dominant. And above 100 degree or nearly equal to 100 degree Kelvin, lattice scattering is dominant. Here when we are increasing the temperature, mobility increases. But after this point, increasing the temperature, mobility decreases. Mobility is proportional to T raised to power 3 by 2. Mobility is proportional to T raised to power minus 3 by 2. So that is the dependency of mobility on what temperature, right? So we are getting question on that. Temperature increases, mobility decreases, because normally we are dealing at 300 degree Kelvin. That is the room temperature. So here we are saying that temperature increases, mobility decreases. But at low temperature, what increases, mobility also increases. So that is a very, very important diagram. Now, so and if we are having, suppose we are having the number of scattering like impurity scattering, lattice scattering or any other defect, because of that there is a change in the mobility, then what is the overall mobility? That is given by this formula. 1 by mu is equal to 1 by mu1 plus 1 by mu2 plus 1 by mu3. That is called add inversely. This is called what? Add inversely. And we will get mu, resultant mu, that is the minimum, less than the minimum of this. जो इसमें से सबसे छोटा है उससे भी कम आएगा, less than the minimum of out of this mu1, mu2 and mu3. So this is the, that is a 1 mark question in engineer that in GATE 2024 guys. Lattice scattering, that is important. Now this graph is important about the mobility. I am going to cover the complete just basic idea about all the semiconductor physics. So quickly watch this. Then guys, this is another one, effect of doping concentration of mobility in silicon. So at a room temperature, again at 300 degree Kelvin, this is the temperature 27 degree centigrade or 300 degree Kelvin. When we are increasing the doping, we are giving more and more and more doping. What about the mobility? Mobility start decreasing. So mobility, for example, at 10 to the power 14 per centimeter cube, that is the doping, the mobility of electron is around 1300. Now when we are increasing the doping, what about the mobility of electron? Start decreasing. At this point it will become 1000 and finally it will become what? 100. Drastic change. Similarly, what about the mobility of hole? When the doping is 10 to the power 14, 500, it is also decreasing. So that is the case. This is a very, very important, or always remember the mobility of hole is less than what? Mobility of electron. So exactly this is the 1300, that is the 500. We are increasing the doping, mobility also decreases for constant temperature. Now, which type of questions? We are having question on this diagram also. Watch this. Same diagram, same question. That is the diagram from standard textbook. And that is the question from that question on this. A piece of silicon is doped uniformly with phosphorus. 1 mark question. Quickly give me the answer. Phosphorus means pentavalent impurity. Pentavalent means ND, donor impurity. With a doping concentration of 10 to the power 16, means it is a N-type bar. N-type bar means we have to deal with the mobility of electron. So this is the upper line is the mobility of electron, lower one is the mobility of hole. So mobility of electron, 10 to the power 16 doping. So where is the 10 to the power 16? 1 into 10 to the power 16. This is the doping. So what is the mobility at this point? This is the mobility 1200. The mobility of electron at that point is 1200 centimeter square per volt second. That is the mobility from the graph. The expected value of the mobility versus doping concentration for silicon assuming full dopant ionization is shown below. The charge of an electron is this much. The conductivity of the silicon sample at 300 degree Kelvin. Again that is based on the graph only. Right? Based on the graph, but very simple question. You have to find the conductivity. So sigma. And Q mu n only. What is the N? N is nearly equal to donor impurity, phosphorus, 10 to the power 16 per centimeter cube. And then what is the Q? 1.6 into 10 raised to power minus 19. And now you have the mobility also. What is the mobility from the graph? 1200 centimeter square per volt second. Now you can multiply it and you can get the answer. Okay, easy question. So that is the use of the graph. So yes, Amrita, at a negative temperature coefficient means temperature increases, mobility decreases because of lattice scattering. It is also decreases because of what? Impurity scattering at high temperature. Okay, impurity increases, mobility start decreasing. Mobility start decreasing, guys, because of the impurity. That is the case for constant temperature also. So this is a very important point. Second one is what? Law of mass action, guys. So you will get the question on what? Yes, that is around 1.92. That is the right answer. Law of mass action means NP is equal to Ni square and law of neutrality. So we are getting question. This is the law of mass action. NP is equal to Ni square, where Ni is the intrinsic carrier concentration. What is the Ni square? Is equal to A naught T cube e raised to power minus Eg0 by kT. Eg0 is the band gap at 0 degree Kelvin. Temperature increases, this is also decreases. This is called band gap. Forbidden energy band gap at 0 degree Kelvin. When temperature increases, Eg decreases. So, and then this is the formula for Ni square. A naught is a constant independent of the temperature, intrinsic carrier concentration, energy band gap, Boltzmann constant, and so on. Mass action law. Second one is what? Law of neutrality. Law of neutrality. Okay. Yes, Np is equal to what? Ni square. Then this is the law of neutrality. Means donor ion is what? Positive ion. Hole is positive. Acceptor ion is negative ion and electron is negative. Charge of electron is negative. Donor ion, acceptor ions. So this is the law of neutrality. These two formula, with these two formula we can solve the questions. They will give you the doping in a particular semiconductor and you have to solve those type of questions, guys. I think you are familiar with these two formula. Use this formula and find the concentration of electron and holes. Then and now the property of silicon and germanium, guys. Sometimes just I am going to want to give this which type of question. For example, any bar is given, Na is given, Nd is given, both are given, Na or Nd both are given, but Na is greater than Nd. You have to find what is the actual concentration of hole and what is the actual concentration of electron, actual concentration. Normally we are saying that it is nearly equal to Na, but if you want to find exact, Np is equal to Ni square. This is called mass action law. N plus Na. Negative is equal to P plus Nd. Negative charge is equal to positive. Law of neutrality. Use these two formula and you can find the exact concentration of hole and you can also find the exact concentration of electron. But simply you have to put here. What is the concentration of electron is equal to Ni square by what? P. Get a quadratic equation and you can solve it. You have the standard answer for that. Okay. You have the standard answer for that, guys. Now, that is another thing to use. Second, what is the use of these two formula? First, this one, concentration of electron and hole. Second one is what? Minimum conductivity. Minimum conductivity, sigma minimum. You have to find the sigma minimum. That is another to find this value. This is a very important topic. Now, what are the important parameters again? Get the idea about, I'm just clicking, but important thing is what? Atomic number for germanium, dielectric constant, that is very, very important, 16 and 12. Atoms per centimeter cube. And what about the Eg naught at 0 degree Kelvin? 0.785, 1.21, 0.72 and 1.11 is what? At room temperature. Intrinsic carrier concentration for germanium is high, for silicon it is low. And that's why the intrinsic resistivity is very low in case of germanium, it is very high in case of what? Silicon. That is the mobility of electron in case of germanium, that is the mobility of electron in case of silicon. This is the mobility of holes, diffusion constant, and what? Power handling capability. So this is a very, very important comparison between germanium and silicon, because we have MSQ. They can give some answers, values, and you have to compare these values. Okay. How to determine the what? Minimum conductivity or maximum resistance. Amrita Khanna, just I am giving you the formula for that, but first, before that, tell me what is the answer for this one. How to find the sigma minimum? I'm going to give you the formula. In a p-type silicon sample, the whole concentration is this one, the intrinsic carrier concentration, the electron. Oh, sometimes they will give this type of question, 1 mark question, very easy. According to mass action law, p-type silicon whole concentration is given. What is the electron concentration? Ni square by p. Use this formula and you can find. Okay, very, very easy one. We can expect this type of question. 10 to the power 5 will be the answer. But sometimes we are doing very silly mistakes. So please remember what is asked. Number of electron is asked or concentration. The concentration is asked, that's why that is the answer. If the number of electron is asked, then remember concentration multiplied with what? Volume. Concentration multiplied with the volume will give you the number of electrons. So read question carefully. Okay then. Then what is the unit of Q by KT? Tell me which answer is correct, A, B, C, D. What is the unit of Q by KT? K is the Boltzmann constant, T is the temperature, Q is the charge of electron. What is the unit of that? Now, how to find the sigma minimum? C is the answer. Joule? No. Or Anubhav Jain have given the V inverse. Acha, theek hai. What is the volt equivalent of temperature Vt? Vt is given by Kt by Q. Its unit is volt. What is the reciprocal of that? Per volt. Volt inverse, simple. V inverse. B for Bombay. Easy. That is the B. Kt by Q is the volt. Now, before solving the sigma minimum, I want to give you one very important information, guys. Take a step towards success in GATE exam. National Scholarship Test. Get up to 90% off on our program. That is on 24th of December, before Christmas. All are ready to give test. 9 a.m. to 9 p.m. Register now for this scholarship test and start your journey with us. And workshop by Richa Gupta ma'am, 5+ years of teaching experience. Okay, on 20th December, and you can ask your doubts here about ideal strategy to be a topper in GATE 2025. Live workshop 7:30 p.m. by Richa Gupta ma'am. Okay, then Fermi Dirac function, that is the another one. But before that, one student asked, sir, how? So how means what? Sigma minimum. What is the sigma? Tell me. N q mu n plus p q mu p. Okay, this is the sigma. Now, what will happen, guys? We have to find the concentration of hole and electron. Before, first of all, what will happen? When we are giving the doping, for example, I am giving the Na here. So concentration, when I am giving the Na, so concentration of hole increases, but at the same time concentration of electron will decrease. Concentration of electron will decrease because of that. Now, what is the mobility? Since the mobility also depends upon the mobility. So initially, when the concentration of hole increases, the P mu P will increase. And the concentration of electron decreases. So what is the mu n decrease? What will happen? This will decrease more initially as compared to that. And the conductivity depend upon the two parameters. So this first parameter will decrease, second parameter will increase, and that's why overall mobility will decrease initially. So then Initially, if this is the sigma, then first of all decrease, then it will increase like that. Here we are giving the sigma minimum. Where we are going to get the sigma minimum? That is the question. So we are giving the acceptor type of impurity. Initially, the sigma will less than what? Sigma of intrinsic carrier concentration. That is clear to you? Now you can find the values here. Then sigma minimum. So sigma minimum means what? You have to differentiate it. So here we have to use the mass action law. So we are using n is equal to what? Ni square by p. So you can write sigma is equal to and p is the variable. To differentiate with respect to p, d sigma by dp, it will become ni square q mu n constant, and what is the minus by p square, that is the differentiation, plus it will become q mu p. Okay, then second again differentiate it, and it will become minus minus plus. Yes, am I correct? That is 0. Means what will happen? If that is the case, it is a positive value, means when we are equating it to 0, it will give you the minimum value. So what is this? What is the concentration of electron hole here? You will find concentration of hole and that is the value for which you are going to get the minimum value of conductivity. Are you getting my point, Amrita or all other students? And that is what mu n is greater than mu p. Since the mu n is greater than mu p, is greater than Ni. Now put this formula here, you will find the electron mu p by mu n, and just opposite ratio, and that's why it is less than Ni. So concentration of hole increases, concentration of electron decreases, and because of that mobility decreases. Now you can put these two formula in this one and you will get the sigma minimum. When we are putting this value in sigma minimum, sigma will become, what is the concentration of n? Q is constant, Ni root over mu p by mu n into mu n plus Ni, what is the concentration of hole? Mu n by mu p into mu n, mu p. Now Ni is common, Q is common, and then this will become root over mu p mu n, root over mu p mu n, 2 times of, and that is called sigma minimum. Is it clear, everyone? This is the sigma minimum. So we are using the mass action law, law of neutrality and so on. तो भी आएगा अमृता, तो भी आएगा, n के रेस्पेक्ट में भी आएगा, लेकिन याद रखना when we are differentiating with respect to n, because देखो अगर p चेंज कर रहे हो ना तो n भी वेरिएबल है, p चेंज करेगा तो n भी वेरिएबल हो गया, तो n के रेस्पेक्ट में ये आ जाएगी n की वैल्यू ni mu p by mu n, ni रूट ओवर mu p by mu n, ये शुरू में आ जाएगा, ये मतलब n कम हो रहा है और p बढ़ रहा है, तभी आपकी कंडक्टिविटी क्या होगी? कम होगी। होल का कंसंट्रेशन बढ़ना चाहिए तभी कम होगी, आप अगर इलेक्ट्रॉन डालोगे तो नहीं होगी, इसलिए मैंने शुरू में ही लिखा है, आई एम गिविंग द Na डोपिंग। ओके, this is very important concept here, don't try to mug up, just try to understand what is this. Second topic, important topic is now, I am doing what are the important topics. Fermi direct function, very important one. So every time we are getting question on that, so I think you have the command over this. Fermi direct function is, first of all, always remember that formula, 1 upon 1 plus E minus EF by KT, where EF is the Fermi energy level, E is the any discrete energy level, K is the Boltzmann constant, T is the temperature. So normally this formula, sometimes they will give you this formula and they will ask question. For example, exactly at E is equal to EF, the probability will become 1 by 2. EF is the Fermi level energy or characteristics energy level. For that, Fe is 0.5 for any value of the temperature. For any value of the temperature that will remain. Then what is the effect of that temperature? This is the curve. When E is less than EF, the probability of finding an electron is 1 for 0 degree Kelvin. When the E is greater than EF, what is the probability of finding an electron? That will become 0 at 0 degree Kelvin. Or exactly at E is equal to EF, it is always 1 by 2 irrespective of the temperature. When we are increasing the temperature, that curve will bend like this. This is the first one, this is the second one, and so on. But it will remain symmetrical, and so on. So that is the Fermi energy distribution, that is the Fermi direct distribution function, guys. Okay. Now, this is the formula. Here, this one very important one. NC is called standard density of state. N is equal to NC e raised to power minus EC minus EF by KT. NC have this value, but that is not important, but that proportionality is very, very important one. Because already we have one question on that, very simple question. NC, density of state in the conduction band. Similarly, NV, density of state in valence band. This is the 3 by 2. Okay, that is the formula. NV e raised to power EF minus EV by KT. That will give you the concentration of hole, and that first one is give you the concentration of electron. Now, for intrinsic semiconductor, we are having, draw the diagram, directly straightforward you will get this question. And here we are having just middle level, EC plus EV by 2. So exactly where is the Fermi level for intrinsic semiconductor? For intrinsic semiconductor, the Fermi level is here, just above this value, slightly above the middle level. Why? Because this is the NV is greater than NC, remember, or NC is less than NV, because effective mass of hole is greater than effective mass of electron. And this quantity is NC by NV, so this is the plus, minus, it will become plus. So EC plus EV by 2 plus half of KT log of NC by NV. That is the gap. This gap is actually half of KT log of NV by NC. Normally what we are doing, we are taking the effective mass equal, then NV and NC will become equal, and then this will become log of 1. Log of 1 is 0. So where is the intrinsic Fermi energy level? At EC plus EV by 2. But it is a electronic devices, guys. ये EDC की क्लास है ना, तो आपको EDC की क्लास में ये याद रखना होगा कि इफेक्टिव मास जो है उस पर डिपेंड करता है. तो ये NC और NV का ये भी फॉर्मूला आपको याद रखना पड़ेगा. You have to use this formula to solve that particular question, guys. To solve previous year question, you will get the idea. This is important topic. This is important formula. Then Fermi energy level in N-type. Always draw the diagram and get the idea. In N-type, where is the Fermi energy level? Near to conduction band. And that is the intrinsic Fermi energy level. And then actual Fermi level near to conduction band, EFN. Remember this gap. What is this gap? KT log of NC by ND. KT log of NC by ND, that gap. And what is this gap? EFN minus EFI, KT log of ND by NI. Two formula only. You can solve any type of questions. So I think you have solved number of questions based on this. It is a quick revision, guys. It is a quick revision, everyone. So are you ready to solve some questions on that? Fermi energy level. Fermi energy level, guys. Fermi energy level for N type. Similarly, you can revise what for P type, guys. This is the P type. This is the gap for P type. To join my Telegram channel, I will upload the PDF on my Telegram channel. You can solve these questions also. Okay. Okay then. Tell me what is the answer for this. तो आप बोलोगे सर कैसे क्वेश्चंस आते हैं, तो ये है देखो क्वेश्चंस. सिलिकॉन इज डोप्ड विद बोरॉन. व्हाट इज दिस बोरॉन? पेंटावैलेंट और ट्राइवैलेंट? टेल मी. बिग ब्रदर. ये है बोरॉन, इंडियम, गैलियम, ट्राइवैलेंट. एंड आप आर्सेनिक, एंटीमनी, फॉस्फोरस is what? Pentavalent. It is Na, means it will become P type. Nd, it will become N type, it will become P type. So Fermi level will goes down. Assume the intrinsic carrier concentration of silicon to be this much. The value of the Kt by 2p, this one. Compared to undoped silicon, the Fermi level of the doped silicon will goes down. It is a trivalent impurity, so goes down. So quickly you can draw this diagram and you will get the answer. As compared to intrinsic Fermi level, it will goes down. Where is the actual Fermi level? Here, near to valence band, EFP, and goes down by what value? Kt log of Na or by Ni, or that is the concentration of hole upon Ni. Finished. And Kt you can directly use, that is the 25, so 0.025 electron volt. Log of what is the Na? Na is given 4 into 10 raised to power 17, that is the boron, and intrinsic carrier 1.5 into 10 raised to power 10. Finished. Take the log, virtual calculator, use virtual calculator. No, Raj, you are using the NV by Na. No, where is the NV is not given, na? With respect to what? Undoped, compared to undoped silicon, the Fermi level of the doped silicon goes down by this value. Goes down. So that gap is required, that goes down. Now, when this gap is required, that is given by what? Kt log of Nv by Na. It is above the valence, that is the highest energy level of valence band. EFP minus EV is this value, Kt log of Nv by Na. EFI minus EFP is that value. You have to calculate the EFI minus EFP. Okay. Be careful about that. Then number of questions on the same formula. Go through the previous year question, that is important one. Okay, for example, that is the another one. You can go through that. In 2020 only 1 mark question you can solve. And then next topic is what? Drift current and diffusion current. Basic idea about the, I am just giving you all the important topics. Please revise all this, and if you find any difficulty, then inform us. Just in special 26 we are covering what are the important topics. So what is the total drift current? Drift current is given by sigma E. So that's why it will become NQ mu N E plus PQ mu P into what? E. That is called drift current density. It is under the influence of electric field. It also depends upon the concentration of electron or concentration of holes. So that is the drift current under the influence of electric field. And that is drift velocity versus electric field. Already I have given. First of all, it will increases linearly, sublinearly, and finally it will saturate. Now, but I am giving you the very important thing. This is the graph normally for what? Silicon and germanium, right? Same graph, drift velocity versus that here. Watch this. This is for gallium arsenide. So they can ask, because gallium arsenide we are designing the special diode. It is a direct band gap semiconductor. This is the graph, guys. Right? Anubhav Jain, what is the weightage of that? So already or not, we have only how many months for this exam? Tell me. Only for 50 days, है ना? अब 50 days पहले अब आज सब वेटेज ही है. And that's why we are taking all this topic in what special 26. Then linearly reach to what maximum. Then it will decrease and then it will saturate. Here we are getting the maximum drift velocity. So designing devices to work here result in a faster operation, and that is for what gallium arsenide. Remember, this is for what gallium arsenide curve. That is from standard textbook. If they are going to give the question, so we are getting some different types of V versus E here as compared to that for silicon and similar material for this one. Okay. Direct band gap gallium. This is the gallium arsenide and similar type of material. No? So slight difference. Here we are getting the, here it will, once it will reach to maximum, it will remain maximum. But here it will reach to maximum, then it will decrease and then it will saturate. Then it will, that is the difference in the curve. Okay. Now, just before entering into the next topic, another important information for you guys. Electronics Engineering All India Open Mega Mock Test from 16th of December to 22nd December already it is started. You can go through our app, that is BYJU'S Exam Prep. Install the app from Google Play Store and start giving what mock test. It is time to give the mock test. Register now for this. Link is given in description. And that is the schedule for this. You can take a screenshot of that. Now, second one is what? Diffusion. You will get question from what? Diffusion. Pulse light method, minority carrier injection. These two topics are very, very important one. So that is the diffusion current density, E or Q, same thing. Q dn by dx minus Q dp by dx. That is the drift because of hole, that is because of electron, diffusion current density. Then that is the Einstein relation. Again, it is very important. dp by mu p is equal to dn by mu n is equal to what? Vt. Motion of carrier due to electric field is called. Due to electric field, what is the motion of carrier is called? Tell me, guys. It is called. Give me answer. ड्रिफ्ट करंट. सिंपल, ड्रिफ्ट करंट. तो ये देखो समटाइम ना ऐसे इतना इजी क्वेश्चन भी आ जाता है, उसमें भी गलत हो जाता है. देखो ऐसे क्वेश्चंस आ जाते हैं. In an n-type semiconductor at 300 degree Kelvin, the electron concentration varies linearly from this to this over a distance of 1.5 mm. The diffusion current density is this one. Find its electron mobility. देख रहे हैं आप how we can solve this question? Concentration. What is the concentration gradient here? Yes. What this? The electron concentration varies linearly from 2 into 10 to the power 15 to 5 into 10 to the power 17. Means it increases over a distance. Like this is the increases like this. And what is this distance? Here it is 5 into 10 to 2 into 10 to the power 5. It increase up to what? 5 into 10 to the power 17 at this point. And what is this distance? 1.5 mm. Right. So 1 centimeter means how many mm? You have to find. Then 1 centimeter is equal to 10 mm. You can convert it into what? Centimeter means it will become 0.15 centimeter. And then you can find the concentration gradient here, dn by dx. n2 minus n1 upon x2 minus x1. So N2 is 5 into 10 to the power 17 minus 2 into 10 to the power 5, 15 upon what? This one, 1.5 mm. Now you can find the dN by dx. Once you have the dN by dx, what is right here? Diffusion current density is, find its diffusion current density. Now what is the diffusion current density? Remember, electron will move in this direction from higher concentration to lower concentration. What about the current? Current will move in opposite direction. Current will move in opposite direction, and that's why that value is given positive, because current is in positive x direction, and that's why the value given is what? Positive here. That is the 360 ampere per centimeter square. So J is equal to what? N. This is independent of the concentration. What is the current density? dN by dx. Now you have the J. I'm not going to solve this, just I'm going to hint. You have the value. You can find the dN and then dN by dx. It is the dN by dx already we have calculated. You can use this value and find the dN. And from the Einstein equation, dN by mu n is equal to what? Vt. You can find the mu n, Vt, mobility of electron. Easy? So this is a 2-mark question. This type of questions we are getting from the diffusion, formula of diffusion, guys. So I think now you are getting which they will ask different types of questions from this. And then now pulse light method is important, guys. This is the pulse light method. With the help of this, we can find the mean lifetime of minority charge carrier, that is the tau p, then tau n. This is the n-type bar. We are sending the light, then it will follow this equation. You revise this. Just I am giving you the idea about the topics, guys. So this is a pulse light method. At this point, turn on the light, concentration will increase, and finally it will saturate. Now at this point, this is the excess hole concentration because of the light. Now the turn off the light, now this excess hole concentration will start decreasing exponentially, and at any time the concentration of hole will become thermally generated charge carrier plus excess hole concentration exactly at t equal to 0 e raised to power minus t by tau p. Tau p is the mean lifetime of what? Holes. Mean lifetimes of holes. That is the formula. You can use this. Similarly, that is, we are having the minority carrier injection. We are giving the radiation. Number of times we have the question on that. We are giving the radiation here. Concentration will increase and the concentration gradient will develop, and the hole and electron will start moving from higher concentration to lower concentration, and there will be current. There will be current, and that current is called what? Diffusion current. So that will be the question. So now watch this. 1 minute. Where is the question here? Okay, so you have to solve this type of questions on minority carrier injection, and then yes, this one. An n-type silicon sample has diffusion coefficient of electron, and the carrier lifetime of electron is this is the repetition here. Then the diffusion length of the sample. Sir, what is the relation between the mu and d, tau and d? And this is the relation. dP is equal to dP tau p. That is the diffusion constant or mean lifetime. This is the diffusion length. So this is the relation, we have to use this. Okay, this is important one. So this is another important formula. You can solve by using this. You can find the diffusion length of the electron by using the second formula. Diffusion coefficient is given and so on. Then next one is Hall effect. So Hall effect is also very important topic for GATE exam. So get the idea about that. These are the formula Hall. That this is the, we are equating the force, and then we are finding what is the Hall voltage, that is given by B into I upon rho W. Rho is a volume charge density. If it is N type, it will become NQ. If it is P type, then it will become PQ. You can find the rho, 1 by rho is called Hall coefficient. You can find the rho, then you can find N or P. You can also give whether it is N type or P type. And Hall coefficient is also given by Hall voltage into W upon B into I. B is the magnetic field and I is the current. So that is the important formula for Hall effect. So remember that. Then an N-type semiconductor specimen has a Hall coefficient of this, RH is given, and its resistivity is this one. The electron mobility we have to find. Acha, Hall effect you want. Acha, you want Hall effect. So I will arrange, because it is not possible to cover complete Hall effect, but I can arrange one session for that. Now what is the relation between that? As you know, Hall coefficient RH is equal to what? 1 by rho. Volume charge density. N-type semiconductor, it is given means 1 by NQ. 1 by NQ. So Hall coefficient, its resistivity is 0.1. So what is the conductivity means? 1 by resistivity. This is the rho is different from that. This is the volume charge density. This is the volume charge density. And that is the way you have the same symbol for the resistivity. So what is the sigma? 1 by 0.1 is equal to, what is the sigma? NQ mu n. Now you have the NQ. So what is the mobility? Mu n is equal to, right, mu n is equal to sigma by NQ. Sigma by rho, and what is the 1 by NQ is equal to RH, sigma RH. That is the formula. Sigma RH is the formula. Sigma is the resistivity. So what is the mobility will? Sigma RH. What is the sigma? 1 by 0.1. That is 10. RH. What is the Hall coefficient here? 300. 3000 it will become directly. 3000 centimeter square per volt second. That is the mobility. So very Hall effect, get the formula right, and then you can solve. Then next one is what? Continuity equation. Next very important one from the semiconductor physics is what? Continuity equation, guys. What is the continuity equation here? Continuity equation means it is based on law of conservation of what? Charge. I have solved one question in 2021 or 2022. We have very important question on that continuity. Already solution is available on the YouTube. You can go through that. That is based on what? Continuity equation. Then this is the continuity equation. How many charge will enter here, and then what is the charge leaving the bar, but that is a very small part of what conductor, then or semiconductor material. Current enter is IP, current leaving is IP plus DIP. At the same time there is a generation of charge carrier, at the same time there is a recombination. So because of generation, because of recombination, and because of that current entering it through the bar, piece of bar, but the charge will remain what? Constant. That is the law of conservation of charge, according to which charge can neither be created nor be destroyed, and that is in this law of this continuity equation is based. That is the important formula. This is a very important one. Remember, the change in concentration of electron with respect to time, the dN by dt, is given by 1 by q dJn by dx plus generation rate of electron minus recombination rate of electron. That will, here the Jn is the current density, right? Remember, this is the, you can directly use this formula, continuity equation. Similarly, whole continuity equation, it is given by minus 1 by q dJp by dx plus Gp minus Rp. Generation rate, recombination rate, where Ga and R represent carrier generation and recombination rate. These two formula are important from the continuity equation, guys. Continuity equation you can solve. In more detail, you can also go through this. That is the continuity equation. dN by dt, n mu n dE by dx, mu n E dN by dx. From where we are getting this formula? From the same formula. From the same, but simply you can replace the Jn by what? Drift plus diffusion current density. What is the drift current? J sigma E. This is the drift current. Sigma is nothing but nq mu n plus diffusion current density is given by q dN by dx. Sigma, remember, nq mu n into E minus q dN by dx plus, not minus, plus. You are putting this formula here in the place of Jn and you will get this one. Similarly, in case of hole, if you are putting this formula Pq mu Pe, that is the sigma E, minus q dP by dx, here in place of Jp, you will get this form. That is the continuity equation, guys. Write this formula 3 times or 4 times and they will give you the idea about the parameters and you can easily solve this type of questions. Continue. This is the important topics. So already I have discussed all the important topics: Fermi level, continuity equation, and what all other topics about the semiconductor physics, Hall effect, minority carrier injection. Please revise all this. This is our leaderboard. If you are giving the mock test from BYJU'S exam prep app, you will get this type of leaderboard, number of participants, these are the ranks, score, okay, everything. Try to give the mock test, install the BYJU'S exam prep app now. Any doubt till this point? Any suggestion? And already we are doing what? Crash course for you, and Vision Gate 2025 and 2026 live classes, recorded lecture, study material, practice quizzes, mock test. These things are required for to crack any exam, guys, and especially for what? Gate examination. To start your journey with us if you want to crack Gate 2025 or what? 2026. If you are in second year or third year or final year, or if you are in job, then you can start your preparation with us, guys. For more detail, you can call at this number. This is our number. This is my Telegram channel where I will upload the PDF of this session. Please go through this. Okay. Yes, I will arrange one session on Hall effect. Within 30 minutes, we can explain that Hall effect. So, okay. Then finally, guys, thank you for attending the session. Like the session, share the link of this session and subscribe our channel. Thank you and good night.